Okay, welcome to another episode of Numbers Microscope. And today we're going to be talking about the weak force, the leptons and the neutrinos. And we'll start out with a little discussion of Higgs, because this makes for some good numerical precursor discussion. Unbeknownst to the Council of European Nuclear Research, aka CERN, an algebraic topologist by the name of Ache Darwadker predicted the Higgs mass years before they found it because of his formula, which happened to be correct, which was 2W bosons plus 1Z divided by 2 equals H. And this is correct. What Ache Darwadker didn't know was that even though he was 99.5% correct with his prediction, there are very, very subtle numerical differences between finding a W and a Z solo and unconnected to the Higgs mechanism. And since they haven't found a ZW boson yet, which I'm sure they will, they don't exactly understand these dynamics fully that connect the W and the Z within Higgs. The formula for the Higgs mass that I just stated, 2 W's plus 1 Z divided by 2 equals H, it gets filled in by 0.919 times 2. Those are the 2 W's. 0.80919, not 803 or 804, which is the conventional value, but an 809 because it is 1/2 of 1618. And in the way in which the Higgs mass breaks the symmetry of the photon, it is necessary to have a 9 in the middle connecting the 8-0 and the 9-1 or the 1-9. This is stuff you can only see under numbers microscope. In any case, the electroweak core features a ring, a triangulated ring of 0.80808 and an oppositely triangulated ring of 191919. Those two values are connected by 6 ones. 6. I only have 5 fingers, but this is 6 ones that connect 0.80808 to 191919. And when you ask those rings to be understood or translated by a very, very special number, 3367, which is 91 times 37, you get 24 and 57. Now this understanding or this translation is what is necessary in order for the leptons and their neutrinos to be partitioned from the electroweak bosons. And this is why the relationship is so very intimate. It is rather extraordinary, it truly is, because these values 2, 4, and 5, 7 govern the neutrino mass mixing matrix. And the neutrino mass mixing matrix, which was initially before the theta 13 value was discovered to be non-zero, could have been tri-bimaximal. And this beautiful word tri-bimaximal is simply an integration of 2-ness and 3-ness, tri-bimaximal, that separates the V1, the V2, and the V3 states of the neutrino into its conventional 3x3 matrix, known as as PMNS for Pontecarvo, Maki, Nakagawa, Sakata. Now the traditional tribimaximal matrix, which is not what it actually is, but is highly relevant, was such that the V1 state of the neutrinos, electron, muon, and tauon, was unitarity partitioned or unitarily partitioned, the wholeness of that field of the V1 state, into 2/3 plus 1/6 plus 1/6, which gives you 1, which gives you the unitarity. The V2 state was 1/3 plus 1/3 plus 1/3, so all the same. The V3 state was 0 plus 1/2 plus 1/2. And so you notice that these parts of the whole, the parts of the one, are these simple fractions. And had that been the case, that the theta 13 value was actually 0, the electron's V3 state, which it turned out not to be, well, that would have been a fabulously, beautifully simple design. Now, even though they tended to push the tribimaximal scheme away as if it was invalid because of this fact, it still has tremendous validity within the realms of dark matter, in the sense that the neutrino veils, in terms of material veils that are ultra shear, could be emergent from the scotogenic realms of dark matter. And I believe that to be the case. That you're going essentially from the mysterious transparency of dark matter into this very, very lightly opaque or opacity field that the neutrinos represent. So these values, 2/3, 1/6, and 1/6 for the V1, turn out to be 68%, 13%, and 18%. Or actually 681, 68.1, 381, 13.1, 838, and 18.6, 813. Those are the exact percentages, and they are very precise displacement values from the tribimaximal mixing. So you can see that 1/6 would have been 16.66666%, which is very, very close to 13.1838, or 8868, and 18.6813. They're very, very close. With the V2 state, you have 263,736 for the electron, 373,626 for the muon, and 362,637 for the tauon. For the V3, for the electron, this is the theta 13 value, it's 0.54945. That means 5.4%, which means that the other two halves are 49.4505% and 45.0549%. That's how the displacement of the theta 13 affects those two halves. So we see, instead of having 50% and 50% for the muon and the tauon in the V3, that it's 49 and 45 with those additional suffix values. So, getting back to the 2,4 and the 5,7, as the 0.80808 and 1,91919 are translated by 3,367, the connection between the electron's V1 state and its V3 state is a 57x value. The tauon's V1 to V3 state is gapped by the value 24x. And then the muon's V1 to V3 is gapped by 33. There is room for sterile neutrinos to be very, very prominent, but that will require some further discussion. For now, we'll just leave this 2, 4, 5, 7, and 3, 3 scenario intact.